Good morning students. Today we will do the second problem of correlation analysis. Yesterday we have talked about a method where we have not used standard deviations. What we are going to do in today's problem is we are going to find correlation using the standard deviation. As you can see here, we are calculating the standard deviation of the X series and Y series. Notice the standard deviation of the X series is given by the formula under root summation dx square upon n. If you have viewed the previous problem, you will see that these are the values that have been found out in the previous problem. The value, standard deviation, this kind of symbol, the bar symbol stands for, like this, एक डंडी और उसके नीचे एक गोला, एक डंडी और उसके नीचे एक गोला. This is the symbol for standard deviation. As you can see here, the formula for standard deviation is under root summation dy square upon n, and then we use the formula for r, which is summation dx dy upon n into standard deviation of y into standard deviation of x. This is the second formula for calculating Karl Pearson's coefficient of correlation using standard deviation method. What we did yesterday was this formula. R is equal to summation dx dy upon under root summation dx square into summation dy square. Now we will use this formula of standard deviation to calculate R. For that purpose, we will take up our second problem. Find the coefficient of correlation between X and Y series. We have been given an X series. See how many observations are there. We have been given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observations. 10 observations of X and 10 observations of Y. We will arrange the given data in the table like this. We will begin with series X. Series X is 17, 18, 19, 19, 20 up to 23. Sorry. What is the total? Summation X is 200. Why do we need to find this? We need to find this because we have to find the mean X bar. Getting it? And X bar is given by the formula summation X upon n. Summation X is 200. 200 upon 10 is 20. Now that we have found out X bar, we will move on to the calculation for the next column dx. And what is the formula for dx? Dx is X minus X bar. So 17 minus 20. What is X bar? 20. 17 minus 20 is minus 3. 18 minus 20 is minus 2. 19 minus 20 is minus 1. Again 19 minus 20 minus 1. 20 minus 20 0. Here too we have 0. Then 21 minus 20 is 1. 21 minus 21. 22 minus 22. And 23 minus 20 is 3. We will find out the total of this column, which is 0. How? what you should do is add up all the minus values. So minus 3, minus 2 is minus 5, minus 1, minus 6, minus 1, minus 7. So we have a total of minus 7. Add up all the positive values. What are the positive values? 3 and 2, 5, plus 1, 6, plus 1, 7. So minus 7 plus 7 gives us 0. Now what we do is we square the values that we have found out here. So dx square minus 3 square is 9, minus 2 square is 4, minus 1 square 1, minus 1 square 1, 0, 0, 0 square is 0, 1 square is 1, 1 square is 1, 2 square is 4 and 3 square is 9. Now we will total up this column values as well. The total is summation dx square, which is equal to 30. Now we will do the same for y series. First of all, we will find out y bar. We note down all the values of the y series. We total them up, which is 160. 12 plus 16 plus 14 plus 11 so on up to 20 is 160. Now we find out y bar, that is 160 here. 160 divided by 10. How did we get this 10? Number of observations is 10. So that gives us the value of 16. Y bar is equal to 16. Now we calculate the dy column. What do we do for dy? Dy is equal to y minus y bar. So 12 minus 16 is minus 4. 16 minus 16 is 0. 14 minus 16 is minus 2. 11 minus 16 is minus 5. 15 minus 16 is minus 1. 19 minus 16 is 3. 22 minus 16 is plus 6. 16 minus 16 is 0. 15 minus 16 is minus 1 and 20 minus 16 is plus 4. We make a total of the dy column and find that it is 0. How do you do this? You add all the negative values. What are the negative values here? Minus 4 and minus 2 is minus 6. Minus 6, minus 5, minus 11, minus 11, minus 1, minus 12. And again there is another one. So minus 12 minus 1 is minus 13. What are the positive values that we have? This is 6 plus 3, 9. 9 plus 4, 9, 10, 11, 12 and 13. So one is minus 13, the other is plus 13. The result is 0. Now we move on to the next column, that is the square of the values of this column. So minus 4 is 16, 0 is 0, minus 2 is plus 4, minus 5 is plus 25, minus 1 is 1, 3 square 9, 6 square 36, 0 is 0, minus 1 square plus 1 and plus 4 square plus 16. Add up all the values of dy square and you get 108. Next is dx dy. Be very careful when you are doing this column, because with so many columns you are likely to get confused and multiply the wrong values. Here we have minus 3. Here we have minus 4. Minus 3 into minus 4 is 12. Minus 2 and 0 is 0. Minus 1 multiplied by minus 2 is plus 2. Minus 1 multiplied by minus 5 is plus 5. Here we have 0. Irrespective of what is there in this column, it will be 0. Again 0. Irrespective of what is here, we will have 0. Next we have 1. Plus 1 multiplied by plus 6 gives us 6. Plus 1 multiplied by 0 gives us 0. Plus 2 multiplied by minus 1 gives us minus 2 and plus 3 multiplied by 4 gives us 12. We total all these values and find summation dx dy is equal to 35. Now we are ready with all the values that we can put into our previous formula. But with this formula we are going to learn the standard deviation method and the formula will be here. You can see the formula. Standard deviation of x is equal to under root summation dx square upon n. Summation dx square is 30. So under root 30 upon 10, under root 3 is 1.732. This is the standard deviation of the x series. Similarly, we find out the standard deviation of the y series, which is given by the formula under root summation dy square upon n. Dy square summation dy square is 108 upon 10 and the answer is under root 3.286. This is our formula. R is equal to summation dx dy upon n into summation dx into summation dy. 25. Where is the summation dx dy? Here. 35. So 35 upon 10 into 1.732 into 3.286 and the answer is 0.61. The value of R is greater than 0.5 and there is a positive correlation of moderate degree. You remember the previous formula? Do you remember it? This was the previous formula, which was the first one that we did. R is equal to summation dx dy upon under root summation dx square into summation dy square. We already have all these values here. We are just substituting the values and we get 0.61 as the answer. So with this, we finish the second type of problem, second formula, and let us meet soon with the third one. See you soon.